Good day everyone. Welcome to all. My name is Sachin Ahankari, working as Assistant Professor in NRCM Engineering College, ECE department. So in this lecture, I am going to give the brief idea about the classification of ICs and IC chip size and circuit complexity. So we will discuss about the classification of ICs in this lecture. So classification of ICs. The mainly ICs are classified broadly into two types, that is digital ICs and linear ICs. So digital ICs, the input for the digital IC is a digital input and the output for the digital IC is a digital output. In similar fashion, for the linear IC, the input is analog input signal and the output is also analog signal. So you are giving the analog signal as an input to the linear IC and analog output will be available. So they are classified into digital ICs and linear ICs. The linear ICs can be easily recognized. So whenever the ICs are used for any applications or for the proper functioning of ICs, if we are attaching the resistors and capacitors outside the ICs, then that ICs are linear ICs. And in the digital ICs, we are not attaching any resistors or capacitors for its operation or for the application of digital IC. So in the digital IC, only power supply, input and output are available. No resistors and capacitors are attached outside of the digital IC. So based upon uh, based upon the requirements of the ICs are mainly again they are classified with the help of different IC technologies, namely monolithic technology and hybrid technology. So depending on the applications, they are classified as digital IC and linear IC, and depending on the uh, different IC technology, they are classified into monolithic technology and hybrid technology. In monolithic integrated circuits, all circuit components, both that is active and passive elements and their interconnections are manufactured into or on the top of single silicon chip. And the monolithic circuit IC is ideal for the applications where the identical circuits are required in very large quantity or in very large scale, and hence provides lowest per unit cost and highest order of reliability. So monolithic ICs, they are known for their higher reliability and lower cost. In hybrid IC technology, separate component parts are attached to a ceramic substrate and interconnected by means of either metallization pattern or by wire bonds. This technology is more adaptable to small quantity custom circuits. So, based upon the active devices used, ICs are further classified into BJT and unipolar. So here monolithic circuit is classified into two categories, that is BJT, bipolar and unipolar. So in bipolar you are using BJTs and in unipolar you are using FETs. So here, based on the active devices used, they are classified into these two categories. And again, bipolar is classified into the two categories depending on the isolation technique used. So bipolar is again classified into PN junction isolation and dielectric isolation, while depending on the FET used, unipolar is classified into two categories, that is JFET and MOSFET. So this is about the classification of the ICs. Now we will move towards IC chip size and circuit complexity. So up to until 1950s, electronic device technology was dominated by the vacuum tube. The present day electronics is the result of the invention of the transistor in 1947. The invention of the transistor is made by William Shockley, Walter Brattain and John Bardeen of Bell Laboratories. And it was followed by the development of integrated circuits. The concept of IC was introduced at the beginning of 1960s by both Texas Instruments and Fairchild Semiconductors. Since that time, the size and complexities of ICs have increased rapidly as shown in the figure. So as shown here, the circuit chip size, the chip size is going to increase as well as circuit complexity is also going to increase. So here in ULSI you are going to manufacture 1 million active devices on the ULSI, where here you are manufacturing 3,000 gates per chip here in the VLSI. So number of gates per chip which are fabricated on the IC are increasing day by day. That's why the circuit complexity is also increasing day by day. So here the chip size, the previous chip size in SSI chip, the chip size was 1 mm by 1 mm, and in MSI chip, the chip size was 4 mm by 4 mm, and in LSI or VLSI chip, the chip size was 10 mm by 10 mm. So chip size is also going to increase day by day, and the circuit complexity is also increasing day by day. So over the years, the device density has increased together with some increase in the chip area. So chip area is also going to increase day by day, since the chip size is also going to increase day by day. So here the chip areas for the SSI chip is 1 mm square uh, and 1 centimeter square for LSI chip. The chip area is also going to increase, that is increased from SSI it is 1 mm square, and for LSI it is 1 centimeter square. So in that fashion the chip size and circuit complexity is increased day by day. Now here if I am going to compare the IC here, the ICs are compared SSI, MSI, LSI, VLSI and ULSI. Small scale integration, medium scale integration, large scale integration, very large scale integration, ultra large scale integration and giant scale integration. So here SSI, less than 100 active devices are manufactured on a single chip of silicon. Here 100 to 1000 active devices are manufactured on MSI chip, while 1000 to 10,000 active devices were manufactured in LSI, and here in the VLSI more than 1 lakh active devices are used for the manufacturing of on the IC. So over 1 million active devices are manufactured in the ULSI. So this is a comparison, and where they are used, the table of comparison and where they are used, it is shown by the comparison of IC table. So I will stop here. In the next lecture I will go for basic information of op-amp and some of the ideal and practical values of op-amp characteristics. So thank you.